Dear friends, in this video, we will discuss a very interesting problem involving the application of normal distribution, where both mean and standard deviation are unknown, and we would like to find the solution in an innovative manner using Excel solver. The art of modeling is very important. First, let me read out the problem. Then I will take you all through a step-by-step approach of solving this, invoking the solver optimization engine in Excel. It's a spreadsheet modeling approach. I'm sure you will gain something very, very substantial in terms of knowledge. Let me read out the problem. In a professional examination conducted globally, 20% of the candidates scored distinction marks above 85. 34% failed in the exam less than 38. If the marks follow normal distribution, find the mean and standard deviation of the marks. We know the standardized normal variable is defined as Z is equal to X minus mu by sigma. And we are going to use the standardized normal ordinate for solving this problem. We are given the information 34% of the candidates fail and the threshold mark is 38. Look at this diagram. I'm just drawing the bell curve and just marking 38 and 85 here. Mu is the mean of the normal distribution, which is unknown. Standard deviation is also unknown. So 34% of the candidates failed in the exam, that is 38 and less. They have got 85 and above, 20% of the candidates got. So what we need to find out is if the probability or the percentage people getting fail mark is 34%, what is the ordinate? Now 38 is not the ordinate. 38 minus mu by sigma will be the ordinate. We have to find out. Similarly, 85 minus mu by sigma is the ordinate here corresponding to the distinction marks, which we have to find out. So what we do here is, in a clever way, we write here, let me model this and show you how to solve this problem. So let me write here, what are the values of, and I put a question mark here. So let me write here in this mean, standard deviation, and I color this here. Sorry, let me put this in the second line because the first line is the heading I want to give here. Okay, let's start like this now. Now, mean and standard deviation are unknown, so I cover this in yellow color. And I write some trial values. Mind you, they are not the final values. We will ask the solver engine to obtain the solution. So mean and standard deviation. And let me just make everything right justified so that we will have clarity. So these are unknown cells. Cell number D15 and E15. Then I write here threshold marks for fail. I write here 38 marks and below is fail. Percentage getting fail marks. Percentage candidates failing. Let me just increase a little bit. It is given here 34% fail. So 0.34. Threshold distinction. Threshold marks for distinction. Is 85 and above. Percentage getting. Percentage candidates scoring distinction. Okay. So let me bring this picture a little closer to us here. Okay. And if required, this part, we can make it like this. Okay, this is it. Okay. Now, percentage scoring distinction, percentage candidate scoring distinction is given as 0.2. All right. Let me make this clear. So this is the position. Now what we do is equation 1, equation 1, equation 2 I write here. Corresponding these two, the ordinates here. X minus mu by sigma is Z, I just put here, is equal to 38 is this mark, first sigma, this cell, minus mu, mean is here, sorry, minus mu divided by sigma, which is here. This is the formula we have to enter. Now, this is equal to, I put here equal, I write a formula here, norm dot S dot inverse. Because we are given probability, we have to get the ordinate. So this 30 x minus mu by sigma must be equal to 0.34. So inverse, norm dot inverse of the probability I enter here, this cell, 0.34. So this is the formula. I'll have to put is equal to as a formula, and I write here 0.34. Sorry. Bracket and 0.34. Let me write this. Norm dot S dot in 0.34. If you double click, you'll get the formula. Norm dot S dot in 0.34 is this cell. The computer returns minus 0.41 as the ordinate. Now the second one is equal to x minus mu by sigma, which is 85, this cell, minus mu, mean as before, divided by sigma as before, and this is equal to 84. Now, as before, If this is 84 and the probability is 0.2, what is the ordinate? Excel has a convention that the cumulative probability is from left to the ordinate, whether it is the left of the mean or right of the mean. So if it is more than 85 has a probability 0.2, less than 85 will have a probability 0.8. Therefore, what I do here is equal to norm dot s dot in within brackets 1 minus 0.2 I put here, which is 80. I can directly enter, but I am writing a formula because whenever the parameters change, we can work it out easily. This is 0.824 the computer returns. Now, I have got everything, but to invoke solver, I need a target cell. The target cell, one of the equations I can write left-hand side minus right-hand side is equal to 0. So the target is nothing but a formula here, left-hand side minus right-hand side, and that is the target. This must be set equal to 0. So let me color this for you again. Let me put a green color. So this must be set equal to 0. The target, just for the sake of clarity, I'm saying again, left-hand side minus right-hand side. Because we need a target for doing solver. This will be set equal to 0. The other one, we will use it as a constraint. Now let us invoke solver, data solver. Those who do not see solver on the screen can go to file and invoke the option part and do that. I will show you here. File, options, add-ins, and Excel add-ins will be there. You put here go and then click solver and click OK. You will get it. You can practice that. So let me go back to solver. The solver dialog box appears. Objective cell or the target cell, which is this green color. This must be maximize, minimize value. In this case, we are not maximizing or minimizing. The value is set equal to 0. By default, the computer does it. So the target is set equal to 0. The target cell is this cell, which you can see. This is the target cell. Now, the next one is, what are the cells that I should change? By changing cells, mean and standard deviation which are there, I need to change. So this is mean and standard deviation which I need to change. So let me just, let me put this again. Here, changing cells, mean and standard deviation. These two cells will have to be changed. Now, look at this. Target cell, $E$20. Changing cells D15, E15. You don't have to remember the cell number. You can just move the cursor. Subject to constraints. Is there a constraint? Yes. What is the constraint? The first equation, we have made it as a target. The second equation, left-hand side, must be equal to. Excel has less than, equal to, greater than equal to, integer, and so on. We want to make this left-hand side exactly equal to the right-hand side, which I put here. So once again, I show you. The left-hand side is this side. Let me show you again. This is the left-hand side. Then the right-hand side is this cell, which is D21. So B21 is equal to D21. Click OK. You have got now defined one. The target cell is set equal to 0. The varying cell is these two cells, which you have marked here. And the constraint is the second equation. First equation, I have made it a target. Left-hand side is equal to right-hand side. That is the cell B21 is equal to D21. Now solve. By default, GRG non-linear is there. Don't do anything. Make unconstrained variables non-negative. If it's fine, solve. Now you got the answer. Mean is equal to 53.46. Standard deviation is equal to 37.48. Signed, sealed, and delivered. Target cell, it is showing as 6E minus 07, which means 6 divided by 10 power 7. If you make this format number as a number format, it will give you 0. So, ladies and gentlemen, it has been beautifully solved using the solver optimization engine. Both are unknown. The advantage of doing this in solver is I can change the parameters and develop a marking scheme. For example, if you are very strict, you do not want to give distinction more than 5%. Let us say, what is the changed solution? 0.05 I put here, and then run solver again, data solver. I put that here, data solver, solve. Now you see the solution. 47.42 is the mean, 22.85 is the standard deviation. So let me put this back again, 0.2, which is the old solution. And I am only showing you, you can change it the way you want and develop a marking scheme. So the original problem solved with this mean 53.46, standard deviation 37.48. Thank you very much. I hope you have enjoyed the innovative way of solving this problem. Simultaneous equation you can do, but it will be a lot harder. Writing a script in Python may be a lot harder. The solver is a magnificent engine which you can use. Thank you. We will see you soon.